Question 1 from the weekly booklet. It is across two topics. It assesses our skills in differentiation as well as numerical methods. So here we go. So first part, they gave us the equation of this function, which is y equals to 2x bracket 1 plus 6 and ln x. So firstly, they tell us that there's a minimum point of A, and they have asked us to find f dash of x, which means we need to differentiate this. So based on all the differentiation skills that we have learned in A2 so far, which will be chain rule, product rule, and quotient rule. So here, we'd like to use the product rule. But if we look into the product rule, it could only be applied with two functions at a time, whereas in here, there are three. That's why, in order to use this product rule here, I need to change it to ensure that we will make three functions into two. So I will open up this bracket here and put it in. So that will be just 2x plus 2x squared and x. So I'll just apply product rule after I put into that form. So please don't use product rule in this position just yet, because there will be issues. So the product rule is given as dy by dx is u v dash plus u dash v. So we'll just use it in the u and v with our u and v's. So u is 2x plus 2x squared, v is ln x. So if I differentiate them with respectively, these are 2 plus 4x and 1 over x. So the product rule is just the cross multiplied and the addition of these two. So we'll have dy by dx equals to 2x plus 2x squared bracket multiplied by 1 over x plus 2 plus 4x bracket ln x. And so you could simplify a little bit. It's not necessarily, but just for our algebra practice. So you could just divide these two by x. You'll have 2 plus 2x. And that one, you could just leave it like that. Well, of course, you could bring this up as a power to change it into ln x to the power of 2 plus 4x. But I don't think that would be necessary in this case. So that would be the answer for part A, the dy by dx. So we'll probably need that for part B, because without looking at the second part, I guess what they're asking us to do is to then attempt to establish an equation to find the minimum point of A, which is, yeah, what they're asking for. So hence, find the x-coordinate of point A, which, if you recall from the graph, it is the minimum point, which we know the gradient at this point will be 0. So bear in mind that dy by dx is the general gradient or gradient function. So I could just set that equal to 0 and then solve for it. So I will just make my dy by dx, this expression there, as 0. So I'll just go use the most simple version here, which will be 2 plus 2x plus bracket 2 plus 4x ln x equals to 0. And then I'll just rearrange. So let me see. Why is it so weird? No problem. Yeah, no problem. Okay, I misread this. Okay, so carry on. So just moving on. So we have we'll just make one of the x as a subject. So we need to guess which one that is from here. But if we just think about how to rearrange an equation, usually we'll just toss the constant to the other side. And so I'll just make a guess. I'll just take a guess. The x that they want us to make as a subject here is this one, because if you look at the answer on the right-hand side, it is an exponential function. So you could only get that if you're reversing the ln function. So that's why I will just make this x here as a subject. So let's just toss everything that is not this x to the other side. So minus 2 minus 2x. And you have also 2 plus 4x brackets ln x, and divide through. So you have minus 2 minus 2x over 2 plus 4x ln x. And so they're all multiples of 2. So divide every number that you see here by 2. Then you will have minus 1 minus x over 1 plus 2x. And so if you want to put into that form, so you could take out the minus sign. So minus 1 plus x all over 1 plus 2x. And then you just raise everything by e to get into the form that they want. So that will be the second part there. So x as required is e to the minus 1 plus x all over 1 plus 2x. And now here, this is the differentiation and the rearrangement that they're asking us to know so far for this question. And now for C, it jumps into the numerical methods. So clearly, the equation that we are dealing with, we can't solve it easily. So that's why we use different strategies to attempt to find that coordinate, the coordinate of the stationary point. Which here they suggest we're just going to use the reiteration approach. So we're just going to change what we had into a reiterative formula, iteration formula. So that's why you could see there are, it's a little bit blurry, but it is n plus 1 and n, which is the base of the x, which means we're going to just reiterate what we got and then just start with it. Okay, so they tell us now xn plus 1 equals to what we have just now. And then they want us to start with x0, 0.46, use it to find x1, then x2, then x3. So so if you want to find x1, that means you're just going to use the formula, e to the minus 1 plus 0.46, 1 plus 2 lots of 0.46. So that will be your x1. Right, so let's just use a calculator to sort this out. So let me get my mouse first. So it's a bit unorganized. Okay, here we go. So we have the exponential function to the power of outside minus first, and 1 plus 0.46, then 1 plus 2 lots of 0.46. And you get an answer for x1, 0.46747. So when we look at the question here, they say they want the values to 4 decimal place. So in order to find an accurate measure for x2 and x3 coming up, so we're going to use the exact value, but the number that you print as the answer should just be 4 decimal place. So that's why you're just going to have 0.4675. Okay, because they not only they want x3 to be 4 decimal place, they want each individually to be 4 decimal place. And so you're just going to use e to the minus 1 plus 0.4674. So put it like that. Dots indicating you're using that number for the next round, because yeah, that's how the reiteration formula works. So in order to use x2, in order to calculate x2, you are relying on the value before it, which is x1. So I'm just going to store this answer. So I can only show you how you could be done using the CG50. So your answer stored to value A. So answer, shift that button answer, and then arrow, and then alpha, and then I want to store it into value A, and then just carry on with what we had. So I'm just going to retype the whole thing, e to the minus fraction 1 plus A, and divided by 1 plus 2 lots of A. And yeah, there you go. You got 0.4684. Okay, so I'm just going to store this answer to B. And this time I'm just going to do the same thing again. So let me just type this into the thing first, and then we'll just store the numbers uh, at the end or in one go in our paper. So 1 plus b, then 1 plus 2b, and there you got an answer for it. So 0.4685 as x3. And then the one before it, if you run it to 4 decimal place, which is, I believe, this number, so 0.4684. All right, and then this number you could get by doing e to the -1 plus 0.4684 multiplied by 1 plus 2 lots of the identical number. And yeah, that will be x1 across to x3. Now, finally, using what you had, which means you're not going to attempt to use your calculator by the looks of the question. So just use what you observed in part C to make an estimation for coordinates of A. I believe they are looking for the X and also the Y. So yeah, if it's just run it to 2 decimal place across x1 to x3 is consistent, it's going to be 0.47. So you will just say the x is 0.47. So we're just going to use it to find the y that you get. So f of x was 2x bracket 1 plus x ln x. So you're just going to sub it into your 0.47. So this time use the 0.47. So don't use 0.4685. We'll just put the 0.47 into your function. So let me check. So 2x bracket 1 plus x ln x. Yeah, I copied it correctly. So do that as well in your exam. Just do a final check. So bracket 1 plus 0.47 and then ln 0.47. And there we go. You got minus 1.04. And it makes sense too, because if you remember the graph, it looks like that. So it should be below the x-axis. So you should anticipate a y coordinate which is negative. So A is 0.47 minus 1.04. Okay, so here's question 1. Question 2. So is a proof by contradiction question, a question that we always fear because there's not really any questions that are repetitive, and it really asks you to think right on the spot, really. Okay, so they say prove by contradiction that there are no positive integers a and b where a must be odd such that that equation holds. Okay, so in proof by contradiction, we're just going to start by assuming the opposite. Let's just write down the assumption. Where the assumption is there exists odd there exist values of a and b, integers of a and b with a odd such that this equation holds. Fine. Okay, so here's my working out right now. Okay, so sad numbers are never nice. So you probably know it since when you start the journey of square roots and the Pythagoras theorem. So that's why you're just going to get rid of it by squaring both sides, and you have a plus 2b squared and a plus 8 times 8ab. All right, so bear in mind that a is odd. Okay, a is odd. Now, so on here, so we could see that if b is even, then that will mean that sorry, don't really need that as well. Okay, so if you just look at a plus 2b squared, so it doesn't matter if b is odd or even, 2b is an even number. Okay, And so if you have a, which is an odd number, add to it, a plus 2b, where a is odd. So if you just imagine 3 plus 6, it doesn't matter. You will always got an odd number. Okay, so this is odd. But if you want to check using algebra, that's fine. So a, because it's an odd number, is 2k plus 1. I'm just going to do this as a rough of hair. You don't need it in the exam. It's just for understanding. So 2b is even. So you could say it as 2n, a multiple of 2 because it is an even number. So when you add this up, 2k plus 1 with 2n, then you could see that when you factor out 2, you have an odd one out. So that's why it indicates that this number is odd. So carry on with our logic. So that means on the left hand side of the equation, if you just square your odd number, it is odd as well. Okay. So now let's look at the right hand side. So 8 times a and b. Okay, it doesn't matter if b is odd or even. Okay, so if you have a 8 in front, then it will dictate the fact that it's just going to be an even number. So if you just imagine um, b multiplied together as either something like um, 11. Sorry, let's not use a prime number because a and b, they're both integers. Let's say if you use 25 for a and b, or if you use 24. So if you do 24 times a, it's a number ends with 2. And if you do 25 times 8, it's a number ends in 0. So they're both even numbers. So that's why this equation never holds, because on the left, no matter what number you are playing around with, a plus 2b all square is always going to be odd. And then on the right hand side, 8ab, because the 8 there, it will just ensure that this expression is always a multiple of 2, which means it's just an even number. So that's why on the right hand side, you could just say that 8 multiplied by that is going to be 2 lots of 4ab, indicate that is even. So therefore, we arrive to a contradiction because you have the left hand side as guaranteed to be odd, whereas the right hand side guaranteed to be even. So that's why we arrive to a dead end. So that's why you could say, therefore, prove by contradiction that there is no a and b with a odd that satisfy this equation. All right. Okay. So as a general tip, like even if you notice how I did this question, this is my first time looking at this question, so I will also experience difficulty. But you just need to think of it from a perspective how you could attack this problem if a is odd. So when it is about odd numbers, then usually you would like to you want to arrive to a contradiction that on the left hand side or right hand side they don't have the numbers of the same nature. Where in this case, i.e., you will get the fact where the left hand side is even, the left hand side is odd, and then the right hand side is guaranteed to be even. But obviously, the first thing you want to do is to get rid of the square root, because square root is very daunting. It's very hard to for us to relate. So that's why you're just going to square both sides, get to this sort of format, and you will have things to work with. Okay. But that is the general idea to handle questions like such, where you're just going to arrive to a contradiction by getting one side to be odd and another side to be even, which is impossible. Question 3 then. So consider the following two events to be independent, i.e. we always write down this formula, probability of A and B, but now in A2, we will probably have seen this symbol already. A intersect B is the same as probability of A times probability of B. Okay, they also gave us the relationship between probability of B and A, and they tell us the probability of A union B. So use it to find probability of B. Okay, so if I want to use a formula to put everything together in a pack, we got that formula there, which will be in 2.4. Probability of A union B is the same as probability of A plus probability of B minus probability of A intersects B. So since I want to just know what probability of B is, so I'm just going to make everything probability in terms of probability of B. So now let's just do the first step by substituting your independence properties here first. So probability of A plus probability of B minus probability of A multiplied by probability of B. And since I just want everything in terms of probability of B, so I'm just going to change the probability of A's. So I'm going to change it into probability of B divided by 2. So it's that one. Okay. And then, so you have 3 over 2 probability of B minus a half of probability of B squared. And so probably you could recognize this already. Hopefully, so this is the probability, this is a quadratic equation situation. So if you make x as probability of B, then you have 3 over 2x minus a half x squared equals 0.52, and then you could just solve it through any sort of equation solving technique app. The calculator could certainly offer you that. So let's just do this. So you go to equation. You could also use solvent if you're doing CG50. Anyway, so let's just get this done and dusted. So 3 divided by 2 minus 0.52, and yeah, you got 2 answers, and that's it. So depending on the marks, so I do apologize, this is not a A-level question in at Excel, so there will be some difference in how the marks are rewarded. But let's say if this is general question that you will see in your A2 exam, so you will want to show the factorizing technique, because otherwise it's very hard to get all the 7 marks. That's just a reminder, but hey, I'm not going to do that. So because I know this question is from somewhere else. So anyway, the answer that you will get for probability of B through the calculator is 0.4 or 2.6. And so because it's probability, 2.6 is off the table. So the only answer for this to work is 0.4. Again, just a several general reminder. So this formula here is true for every case. So it's true for any questions that you could possibly imagine, really. So even in tree diagram, this is true when this is event A and this is event B, where this probability here is probability of B given A. Yeah, but in generally speaking, when you find a probability of B, if you toss it into this formula, it still works. Okay, so this formula that I just put in circle, it doesn't matter what the case is for A and B in Venn diagram situation, be it independent, mutually exclusive, is always true. So you could always save to use that. So it's just that there's a mutation here when it changes into the second line. This is only true when A and B are independent. Okay, So be careful with that. So remember this thing that I circled, that I put in circle, is always true. So you could use it for especially Venn diagram questions. You could always get something out of it. Finally, question 4. Uh, this is a projectile question. So it's our first time, I believe, looking at a projectile question. So hopefully it's going to be fun. So they say that there's a golf ball that is being projected from a horizontal ground level, and then they gave us the velocities in components already, which is nice, which means I don't need to do any sort of resolving work. And then they tell us it's going to arrive to the floor again at point A, where OA is 120 meters. Use it to show the initial, the U is 40, where U is the vertical component, the vertical speed only. And yeah, and then part B and part C is other sort of problem solving technique. So just a reminder that the distance OA, where since I project from point O and answer the floor, we call this distance the range. Okay, so this is the range that this projectile has made. So this is going to be 120 meters, it tells that. And in this projection, our speed could be broken down into U and 3U, where 3U is a horizontal component, this is the vertical component. Okay, so let's just fill in the things that we know in default, no matter if we're doing A, B, or C. So in the default setting in projectiles, we'll always resolve into horizontal and vertical dimensions, where horizontal, because there are no force acting on it, so it's just going to travel under the same condition, under constant speed. So in the horizontal direction, I always just enjoy doing this. So I know A is 0, so just put down your speed there, your distance there, and your time there. So your speed there is going to be 3U, and then that will be what you could fill in as default first. And then in the vertical dimension, so initially we're moving outwards, so you could take out as positive. So SUVAT, so the default stuff that we could fill in is the initial velocity, which is capital U, and A, which is minus 9.8. Okay, so these are the default stuff. So I'm going to put in red. And you could use it safely across A, B, and C because these are initial conditions, and because there's no change in acceleration, there's no acceleration, which also no change in acceleration for the horizontal direction. Therefore, these are always true. So I'm just going to take a screenshot of that, and then I'll let you see that it is just what I'm going to use for A, B, and C. All right. Okay. So for part A, I'm going to show that U is 14. So far, they just gave us the range as if. Okay. Actually, they also tell you one more thing. Okay. So here, based on part A, I could then additionally fill in the horizontal distance travel is 120. But they actually also tell us one thing. Since I start at point O and I end at point A, where both points are on the floor. So actually they secretly tell us this number as well, which is the vertical displacement. That will be 0 because I end at the same point vertically speaking. So we end at the same level vertically speaking. So therefore, from here, we could get something out of it. Bear in mind that this number here, which is the time taken for you to go from point O to A, both horizontally and vertically, they has to be the same. So that's why you could just make use of these two facts to show that U is 14. So firstly, look, if you look at the horizontal dimension, so you could calculate 120 you in terms of UNT, which will be the speed times time here. 120 is the same as 3u multiplied by t. And then vertically speaking, you could find you could establish an equation linking up u and t without v, which will be s equals ut plus a half at squared. So you will have 0 equals ut plus a half times minus 9.8 t squared. That is bracket not 9.81. Okay, and then so you could just solve those two equations together simultaneously to get to u as 14. All right, so here we go. So you have so you want to show u, right? So that let's just make t the subject here. So t is going to be 40 divided by u. So you just toss it into those two things. So that will just got cancelled and get 40, but I'm just going to show you that. So 0 equals to u times 40 divided by u plus a half times minus g multiplied by 40 over u squared. So that will be, that is 40, move it to the other side. At the same time, minus 40 minus 4.9 times 1,600 over u squared. So which means you have to zoom out. So you have u squared equals to 40 divided by, oops, let's not do that. So you have you have minus 4.9 multiplied by 600 divided by minus 40 equals to u squared. So you have u squared equals to, let's just get to the basic calculation. So minus 4.9, so 4.9 times 1,600 divided by 40. Okay, so you have u squared equals to 196. So bear in mind, this is a quadratic equation. So I know u is just 14 at the end, but you need to respect this is a quadratic equation, which means there should be two answers. So that's why you just write u is plus or minus 14. But then because we know that for this to make sense, for you to hit a golf ball and perform a projectile motion, it means that u has to be positive, because if we make u as minus 14, it means that the golf ball goes this way. Because if u is minus 14, that means we're going below where we start. But we know based on our observation in real life, the golf ball never goes that sort of pathway. So we're just going to pick u as 14. Okay. So I'm just going to conclude that because u has to be positive in this case, so u is 14. Okay. So that is part 1. And now let's look at part B. So they say that so use what we have obtained, the initial velocity, to show to find the speed of the ball immediately before it hits the floor. Okay. So firstly, if I'm going to draw the combined speed at any sort of projection, any sort of position in this parabola, this is my direction. This is the speed that I'm traveling at. This is the combined version. Okay, so here they want us to find the speed right before it hits the floor. Okay, so certainly this is not 0. And if I want to find the size of the speed, i.e. the size of this arrow here, I could just break it back down into my horizontal and vertical direction. So now we know since u is 14, so I could change this. So that is 14, and that is minus 42. All right, and so again, you have everything that you need because if I just model this silver from point O to A, we know that vertically speaking S is 0. So I could just solve it without t. So you have v squared equals u squared plus 2as. That will be 14 squared plus 2 bracket minus 9.8 times 0. And surprisingly, maybe not so surprising with some of you here, v squared is 14 squared and v squared is 196. Again, this is quadratic, meaning v is plus or minus 14. Now, this time, which one should I pick if I want to indicate the vertical speed here? So it has to be minus 14 because I'm going downwards in this position. So the minus here will be contribute to the direction arrow here. So the size of this arrow, I still put it as 14, but in terms of the answer that I should choose in order to find the speed at point A, I'll pick the vertical component here to be minus 14 because at point A we are descending still, and then so the horizontal direction, bear in mind that it never changed, is positive 42. So you could just use it together to solve for part B there, which will be the speed square root of 14 squared plus 42 squared, and then you can answer all of it. And so we will have square root. Where's square root? Square root of 14 squared plus 42 squared, and you can answer for it. So 14 root 10, or in other words, 44. So make it as 44, right, to just two significant figures, that's fine. Obviously, put a better answer on top if you just fear they will they are looking for a better accuracy. So 40 root 10, that's the exact answer. Okay, so now the most exciting part C. So part C, they say find the values of t so that the ball is moving at an angle alpha to the horizontal, where it's defined to be a quarter. Okay, so let's just try to understand what they are asking for first by looking at what does that mean with angle out with an angle to the horizontal. So when we start projecting a ball, we project based on the numbers given. We project with a speed of 42 and horizontally and vertically 14. And we have undergone this motion. So in the starting point, we can actually model the angle, the direction of motion, the direction that the ball take as the point of projection. So I could just use this triangle again with 14 and 42. Let's call this angle A. So we know tan angle A is opposite over adjacent. That will be a third. Okay, and then we'll say that this is an angle A above the horizontal. Or if I just solve the answer first, so that will be, let's just make sure it's degree it is. So tan inverse of a third, it will give you 18.43. So usually the way that we're going to describe the projection at the start, we'll say that this is an angle 18.3 degrees above the horizontal, because I did project it above the horizontal for it to be a golf ball motion. Okay, so how does that help me to understand this question here? So let's see. They say they want us to find the instant where the ball is moving at an angle alpha to the horizontal. Okay, so that means if I'm just going to pick some position here at this problem, so let's say this point here, So they're saying this when we're going to find the direction of motion in terms of the angle, they want to say that this angle is going to be, if we're going to use the geometry ratio, this is going to be a quarter. And since here, unlike what I've done in the starting position, they didn't indicate that it is either above or below. That's why there are two positions that could actually fulfill this. So one, when we are on our way going up, which is something like that. So this is an angle alpha to the horizontal, or alternatively, it could be this one here, which is also angle alpha to the horizontal, because it could be above or it could be below. They didn't tell us. So all they tell us really is that if I attempt to solve this angle, tan alpha is a quarter. Okay. So again, using the default setup now, when I'm attempting to solve this question, we know that this is 42. So no matter where I draw the vector, the direction vector, we always know that this component here is 42. This is 42. This is 42, because this is the way that we modeled the projectile motion. So the horizontal component has to always stay constant as 42. So that means we have this number here to be 42 always. So the only thing that could really change or help us to construct the direction of motion to exhibit this sort of a property, tan alpha equals to a quarter. The only thing that we could change here is this vector. So I'm just going to now attempt to find the size of this this length, which is the vertical component at those two instances. So if I call this V, then we could just use the triangle here. Tan alpha is a quarter, or it could also be found through this triangle, the opposite V over 42. So I could rearrange that to find the vertical component. So V could be a quarter times 42. Okay, so bear in mind this is just the size of this triangle here, the size of this length here. So that's why it could be either positive or negative, because this one is pointing positive, or this one here pointing negative. So that's why here you could just proceed to say that V actually could be plus or minus a quarter of this number here. And therefore you could just use this as your final vertical component, where I'm going to put it down here right now, positive a quarter times 42, where the rest doesn't change. These are all the default setting, if you remember, and to solve the problem. So therefore here, I'm just going to do V equals U plus 80. So I have positive a quarter times 42, and then minus 9.8t. So I'm just going to separate into two avenue now. So one as positive, another as negative, and finish it off. So we're just gonna pretty much rearrange the equation. So I'm just gonna do it in the calculator. So that will be a quarter times 42. That's 10.5. So plus or minus 10.5. So that number here minus 14 divided by minus 9.8. That's the first value of t. Again, write to two significant figure will be suffice. 0.36, or you're going to use minus 10.5 to start with. This number here, just minus 10.5 will do. Minus 14 divided by minus 9.8. And there you have it, 2.5. Yeah. So this is a Pujata question, and so I hope you enjoy this question, and there will be more to come the week after.